and Assalamualaikum. So for today we are going to present about our ship selection, the ship that we decided to build in this subject, which is naval architecture. So this is our group members. Me myself is Nurul Nastasha bin Rahman, and we have Yo Kian Weng, Siti Sarah bin Ismail, and Muhammad Hakimi bin Azhar. So the first one is selected design, which is we decided to build a container ship, and for this presentation, there are four topics that we are going to discuss in this presentation, which first one is ship selection, and then hydrostatic data calculation, and proceed to topic number 3, stability assessment, and the last one is design justification.
For our assignment, we choose container ship for our ship selection. Our ship is built with the specification of ship with size of length 397 meter, the width is 56 meter, and the height is 30 meter. The light weight is 61,881 tons, and the deep weight is 156,907 tons.
So the next topic is hydrostatic data calculation, which we will calculate four of these component, which is cross-sectional area and then volume, the longitudinal moment, and second moment of inertia. So this is the formula that we use to calculate the cross-sectional area of the ship by using the Simpson's first rule, calculation based on area under graph. So to make it easier for us to calculate, we use table like this. For example, for the light ship calculation, which the weight of the ship is only 61,881 ton, while the draft is 11 meters high, and the size of breath is 20.53, and half of the breadth, which breadth divided by 2, and then the total length is 356, interval which we divided by parts, the section of the cross-sectional area, into 10, so it becomes 35.6 for the value of H. So as you can see from here in the table, the section, this one is A, and then B, C, D. D is area of product, which value of B times value of C, which is the combined one, and we get the area product. And then sum of all of this area of product, we have total area of 157.4, which we insert it into this equation for area, which 2H equal to 35.6 and divided by 3 as in formula, and then the total of area product, this one is 157.4. So the area for light ship is 3,735.627 meters square. So next is loaded. For our ship, when loaded, as the weight is increasing, the draft will increase too, since the ship will sink further. So the length of cross-sectional area that we choose is 376 meters. So the interval to be inserted in the formula H, which by 10 section is 376 divided by 10 is 37.6. So just like same as previous calculation, the total area is 488. So insert it into this equation. So the area for our loaded is 12,232.53 meters square. Next one. So the last one is ballast condition, which the ballast we use to stabilize the ship when there is no load or half load, half ballast. So the weight of the ship in ballast condition is 156,094 tons, and the draft is 14.75 meters. So the breadth is 31.6, and half of the breadth is 15.8, which will be used for point B, which is half ordinate. And the length is 366, so the interval for H value is 36.6, since we divided into 10 sections, same as previously. So the total area product that we multiply point B and C combined is 267.2. So insert it into the formula. So the area for ballast is 6,519.68 meters square.
Hello, my name is Okenge. I'll begin on the word composition of the ship. The ship cruiser is container ship with a triangular vessel. The formula used is V equal to half of length times breadth times draft. We got three conditions: light ship, loaded, and ballast. Light ship condition is a ship complete in all respects without consumables, all cargo, crews, and effects, and without any liquids on board except that machinery and rubber fluids. In light ship condition, the draft is 11 meter, the breadth is 20.853 meter, and the length is 356 meter. The one calculated using the formula is 40,197.74 kilometers. Next, the water condition. Another condition is when a ship is loaded with cargoes containers. When a ship is loaded, its draft increases to 15.5 meters, the breadth 56 meters, and length 376 meters. The volume of the ship in this condition is 163,184 cubic meters. Lastly, the ballast condition. Ballast condition is a ship remains in stability without containers or weight using the ballast system. The draft will decrease to 14.75 meters, as well as the breadth and the length, which is 31.6 meters and 366 meters respectively. The volume of ship in ballast condition is 85,296.3 cubic meters. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakimi bin Azhar. My method number is B09201048. Okay, so we continue. The longitude moment. To calculate the longitude moment for the lightweight, the KB is first determined using the formula 2/3 times the draft, resulting in 7.33 meter. The BM is giving the value of 0.86 meter. The KM is calculated by added KB and BM, resulting in international value of the 8.19. The GM is calculated as negative 9.31, and the weight of the light sheet is found to be C188 tons, C1881 tons. Assuming additional weight to total weight become 72881 tons, with a moment about the kid of 1195417.5. After dividing the final moment by the final displacement, we find the final kg to be 18.14, resulting in the final GM of negative 9.94. Okay, we continue again. The longitude moment of the loaded ship in calculate using the different draft to the lightweight, resulting in a km of 19.33 and the weight of 170,974 tons. Using information provided in the table, the total weight is found to be 181,974 tons, with a moment about the kill of 30720445. The final kg is calculate to be 17.97 with a final GM of 1.36. The weight distribution of the load object or discrete, with a object containing 7,000 container with a average weight of 24 tons, totaling 1C8,000 tons. Okay, we continue. Lastly, ballast. The passenger detail the calculation for a ship ballast condition. The KB and BM are calculated as 9.83 meters and 1.61 meter respectively, along as a value of the S, kg and GM. The weight kg and moment about the kil of each component are given. The final kg and GM are calculated as 10.44 and 1.00 respectively.
Assalamualaikum. My name is Fisara and I will present the second moment of inertia for this assignment. So basically we use Simpson second rule to complete this section. So this is the formula that we have used for this part. First is the AW, which is weighted surface area, and then the LCFMS is center of flotation for merchant shipping. IMS is the initial merchant shipping. IF is the initial transverse distance of mass element, and the ICL is for initial container load. And lastly is TCFCL, which is the transverse center of flotation for container load. And for this formula, we can get from the Simpson rule that we have done. So first, this is the second moment of inertia for loaded ship. The weight of the loaded ship is 170,974 tons. The drop is 15.5 meter and the weight is 56 meter. The length for the ship is 376 meter. So we can get all these value from the Simpson rule, the table of the Simpson rule. So for the weighted surface area, which is AW, we get 12,232.53. The LCF MS, which is the center of flotation, is 188. The initial for merchant shipping is 512.8623.6. The initial for transverse distance of mass element is 508538897.1. The initial for container load is 141,376. The transverse center of flotation for the loaded ship is 0. And next is the second moment of inertia for the lightweight ship with weight of 61,881 tons. The drop is 11 meter, the breadth is 20.53 meter, and the length is 356 meter. So by using the same formula from the previous slide, we get the weighted surface area is 3,635.627, and then the LCF we get 178, the initial for machine shipping, we get 136750901.8, the initial for transverse distance of the mass element, we get 135567305.8, the initial for container load, 126,736, and then the transverse center of flotation for container load for this ship, also the zero. And the last type of the ship is banner ship, the second moment of the inertia with weight of 156,094 tons. The drop is 14.75 meter, the weight is 31.6 meter, and the length is 366 meter. So use the same formula and the same calculation, which is the Simpson rule. We get the AW is 6,519 for 168. The LCF is 178. The initial for machine shipping 24258931.8. The initial for transverse distance of mass element 240405956.1. The initial for container load 130,296, and the TCFs for container load for banner ship is also 0.
So next part is stability assessment of our ship. The purpose is to determine the stability status of the ship. So the first one is initial stability check for three condition of our ship, which is like ship, ballast, and loaded, to check if the ship is possible. To check the possibility of the ship to capsize. And the first one is light ship, which we calculate the value of GM is we get negative 9.94. This is because this is just the ship itself without load. And from this, when the value of GM is negative, it indicates that the G position is higher than meta center as illustrated in this picture. So the ship has negative stability and the possibility to capsize is higher. And next is ballast. So in ballast condition, to counter the light ship stability condition, so in ballast we have GM value of a positive one, which is 1.36. So we have positive stability for this condition, and while loaded, also more than uh, more than one. Can we call more than one positive value of GM? So it has positive stability, which makes the possibility of this ship to capsize in ballast and loaded conditions lower.
So next, this is the intake stability check. GZ is the writing level. So we use the formula of GZ equal to GM sin theta. So basically we have three types of condition of ship, which is lightweight ship, loaded ship, and ballast ship. So the lightweight ship, the GM is negative 9.94 meter. So then the data is negative 14.20 degree. So by using the formula, we get the GZ equal to 9.92 meter. And next is the loaded ship with GM 1.36 meter. The data is 52.16 degree, and the GZ is 1.29 meter. And lastly is the ballast ship with GM 1 meter, data with negative 17.64 degree. So the GZ is 0.94 meter. The writing level GZ should be at least 0.2 meters at an angle of heat equal to or greater than 30 degree. The maximum writing level should occur at an angle of heat not less than 30 degree. The initial transverse lateral heat should not be less than 0.15 meters.
Next is the design justification of the ship. The GZ value refers to the writing level, which is a restoring moment created by the ship's stability characteristic when it is sealed. A positive GZ value shows that the ship has a writing moment that tends to restore the ship to an upright moment when it is sealed, while a negative GZ shows that the ship lacks of writing moment. It has a destabilizing effect when it is sealed and cause the ship to capsizing. So we got three conditions. The light ship GZ value is 9.92 meter, the loaded GZ value is 1.29 meter, while the ballast is 0.94 meter. So we can see that all the user value is positive, and we can consider the ship design is safe and possible.
So we continue. Conclusion. Ship design and operation require hydrostatic data calculation, stability evaluation, and design justification. They keep very safe, stable, and performing throughout their lifespan. They summarize their maritime industry main areas. Ship design operation depends on their characteristic. They help designers and operation understand ship behavior, ensure stability, and meet regulation. Intensive computation and analyze and justification can increase ship safety, efficiency, and performance for various applications. That's all for me. Thank you.